Hi everyone, and welcome to another video of Programming for Data Analytics. I am your host, and today I will be covering classes. So, what are classes? Well, classes are actually something that's not related to just Python. And it kind of comes from the concept of object-oriented programming. So let's talk about what object-oriented programming is and what it can do for you and your programming. Now, there's a lot to this topic. In fact, we spent a couple of weeks on it in our normal computer science courses, and I do have those courses on my YouTube, but for C++. So I am going to give you a bit of a crash course and only focus on the important things, but there is a lot to learn about object-oriented programming and how classes take into effect. But first, let's kind of analyze what the concept of a structured data is. So far, when you've been creating your data, you have either created individual pieces of data, such as integers, strings, floats, floats, I was gonna say, well, floats are doubles, but they're called floats in Python, so yeah, and so on. And what if you needed to keep two integers, like an x and a y coordinate? Well, you would just make two integers, right? And so you have these floating around. So let's just go ahead and give them some names. So we're gonna say x and y, and maybe the float is some z value, and the string we're gonna call L for label or something, right? So if you have a couple of these and you say, well, these represent coordinates x, y, z, and L is like some data or some label, and I want to store multiples of these, the only thing that you knew how to do so far was to create a list, right? So you went ahead and said something like, we're going to call this L, and we're going to basically put all of them inside like that, right? And so if you wanted to make multiple of these, then you could just make multiple of these lists with new bit values for x, y, and z. Obviously, don't put the same ones in, and so on. And if you wanted to make a lot of these, what we said we could do is a multi-dimensional array. So, we can make something called D for data, and then you can make that empty, and then you can just say D dot append, and then put in your L, and then also put in your L2 in there, and so on, right? And that is one way of keeping your data structured. However, only you know the ordering of this, because like suppose that I went ahead and did this, I appended both the L and the L2 in here. If I want to access this value right here, this would look like something like this: D index 0, and then index 0, and that is the equivalent of the x. If I wanted to access this z, for example, then that would be D index 1, and then of this would be 0, 1, 2, so index 2 here. And that would be basically the equivalent of the z, right? And so on. So you have to keep track of these values as they represent a list of them. That's more normal. But the weird thing is here, right? Because you're using numbers to access different types of data, and you have to keep track of, well, that the second number is a float and this one's a string, and so on. And from a coding perspective, when somebody sees a line of code that just has numbers and letters like this, like something very basic like this, they can't really know what this contains. So your code is not very readable. And while this will work, and that is thanks to Python's ability to have a heterogeneous list of data, that's basically a layman terms of that is just saying that, a list in Python can contain different types, whereas other languages like C++, they have to be homogeneous, so they have to be the same type. So like you can only make a list of integers called an array, or you can make a list of strings called, array of strings, array of integers, array of floats, but you can't make an array of like multiple things like you can in Python. So even there it's more important to know how to do structs. So how do we go around this issue? Would it not be nicer if we somehow created a data where we could say something like instead of saying L22 we'll be able to access Z or L2 1 to be able to access the Y, or L2 0 to access the X. Instead of having to do that syntax, wouldn't it be much nicer if we could say something like L2.z or L2.x and refer to them by the variable name? That would be much more readable, because now if I want to assign, like, let's say this value here, I can say, you know, this value of D1 dot, and then let's say I want to access the X, so I say dot X. That's much better than saying D1 0, right? So that is what we're going to be achieving by using classes and objects. Okay, so let me just start by showing you a class and then talking about like the concept behind object-oriented programming and why classes work the way they do. Okay, so suppose that we want to make this class that is going to contain this data that I said, so the X, Y, Z, and the L. And the way you do that in Python is you're going to use the keyword class, and you're going to give it a name. So in this case, what do we want to call these? We're just going to call them data. You put your colons like if you were writing a function or a for loop or something. And then inside of that, you're going to have to create a special function. And this function is called, in a lot of programming languages, the constructor. Here, it has the word init in it. You put 2 underscores. I'm going to put a space there, but really they look together like that. Okay, it's 2 underscores. Then you put the word init for initialization. And then you put 2 underscores again. Again, I'm putting them together, but it's 2 of them. And then you have to write the word self. And this is actually what's known as a reference to yourself. And again, this is the part where I'm going to be skipping some things because this is not a multi-week lecture. It is a single day lecture. In fact, it's a 1-hour lecture basically. So, you know, cutting corners here, but there's a lot of theory behind why that has to be there. Okay? And from there, that's technically all that you need. But in this case, I'm going to go ahead and throw in some other information here, which are going to be the list of variables that I want to create when I create an object of this type. So I'm going to say something like my X, my Y, my Z, and my L, lowercase. Okay? And this, as you can see by the word def at the beginning, is a function. So I need my colons as well, and I need to indent the next line. So in here, this is going to be running a piece of code every time you make this object of this type. So for now, all I care about are creating these variables that are going to live in here. So what I'm doing is, you can think of it as I'm creating this new data type. So I have integers, floats, and whatnot. Now I'm also going to have one called data. And I'm saying, what do I want this to contain? Well, I want it to contain an integer. I want it to contain another integer. I want it to contain a float. And I want it to contain a string. And it has a self thing that we don't really talk about. Okay? But I got to give them names, so I'm going to say X, Y, Z, and L. So in here, I'm going to write the word self. I'm going to put the dot, and then I'm going to put the name of the variables that I want to call them. So I'm going to call X, Y, Z. And L. Let's move this out of the way a little bit. Next, this could be enough, but what I want to do is I would like to fill these up with data that I use when I create this. So I'm going to say my X, my Y, my Z, and my L. Okay? What I'm saying is, when I create this data object, just like when I create an integer, when I create an integer, it's as easy as saying bar equals 5, right? So I'm giving an identifier name, and I'm filling that information of the integer. In Python, in some languages you can, but in Python, you can't just create an integer. You need to put something in there, right? Otherwise, like in C++, you can say something like int bar, and that just creates an integer value. It has nothing in it, some garbage, whatever, but it's just created. You can't really do that in Python. you have to fill it with something because it needs to know that this is an integer in the first place. So you fill it with some information. You want to create a float, then you do the same thing. You say v, and then you got to feed it actual float value. If it's a string, then you have to feed it something with quotes, right? And so that's how you basically create variables in Python. In this case, we're making this new variable type called data, and it's the same thing. We are going to have to fill it with some information, and that information is what I'm doing right now. I'm saying this is not just something that takes one piece of data, it actually takes four, the X, Y, and Z, and the L. Now, you don't actually have to, you'll notice that I'm using this word my in front of it. You don't actually have to do that. You could name these X, Y, Z, L, and this would work the same way. But I didn't want to do that in the beginning to confuse you. These are just temporary variable names to what you're going to initialize. That's why this is called init, to what you're going to initialize the member variables. So we call these variables here the member variables of the class, or the fields of the class. And so that means that whenever we create an object of data, we are going to have an X, Y, Z, and L as part of it. Now let's talk about this dot. This dot, you have seen it before, occasionally throughout the semester. First of all, that dot has a name. It's called the member access operator. And as the name implies, it accesses members of a class or an object. So X, Y, and Z are members of this club called data, per se. It's a club. And you want to access any members of it, you say data, and then you list the member name. Okay, so like, let's say Nintendo club. And Nintendo has Mario and Luigi as part of the members, right? You want to access Mario, you say Nintendo.member Mario. Or Luigi, you say Nintendo.Luigi, and so on. Okay? So that's basically what the dot means. And the reason why you're putting here the word self is because you need to explain that this X belongs to the class. That's as much as I'll say about the self for now, or in general, because again, it's we're putting a lot of information here on the fly. That's it. That's really all you need to create this data type or this class. So how do we use it now? Well, suppose that I want to make this data that I want. I want to make L2 or L1. So if I want to make an object of this data, and you call it an object, you don't call it like an integer, flow, or just call it data, you just call it an object. So I want to make an object of data. What I do is I give it an identifier just like anything else. I'm just going to call this L2 for some reason. And then I'm going to use my assignment, just like if I was creating an integer. But instead of feeding it a number or feeding it a set of numbers, what I'm going to do is I'm going to give it the name of the object type. So that's the data, because we called it data, right? That's why I'm giving it that name. And then I'm going to put parentheses, kind of like if it was a function call. And in those parentheses, I'm going to put in all of the things that I want to initialize this object with. So that's the 4 parameters here that I have, 4 arguments. So let's say I have X, Y, and Z. So let's say I'm giving it a 5, a 4, a 3.1, and a high. Now I have created an object, and if I go ahead and say type, remember the type function, you're able to print out whether something's a string, an integer, or whatever. So if I say type on like, if I say like bar, it gets 5, and I say type bar, this is basically print out the word int, right? And then you can also use the instance of or is instance. I forgot which it's instance of or is instance. I think it's instance. Yeah, it's instance. And then you pass in like the variable you're caring about and then the type, and you see if those are equal or not. That's basically going to return to you now this custom object type that you've made. And so in this case, I have made this object, and this object contains all I want. So now what if I want to print out the Z value of my object? Well, I will say print, and I would say L2 dot member access operator, and then Z, because that's what I called it up here. And this would print out to the screen 3.1. I can also change values the same way. So I can say like L2.x gets 20. And that's going to update basically that guy here to 20. So if I go ahead and print it afterwards, then it's going to print out 20. The big advantage here is readability. As you can see, this is much more readable that we're putting the, of course we called it Z, but like I call it whatever I want, and that's much more readable. Okay, so let's jump into code and let's go ahead and do another example of this, but see it running. So I'm going to go ahead, let's say that I'm dealing with data and I'm dealing with a bunch of student data, okay? And I'm trying to process some data that I'm reading in from a file, and that file contains student data. Or actually, you know what? Yeah, well, we'll do a student data example. I was gonna say we could do the COVID data that I have, but student data will be easier. So let's just say that I have a CSV file that contains a bunch of columns that are different data for student, or I'm just making it on the fly and people have to enter it in, okay? So first of all, I need to define what my class type is going to be. So I'm going to call it student type. Okay, next I'm going to go ahead and write that initializer function. As you can see, I'm putting 2 underscores. I can also use the tab key and it will autocomplete, as you can see there. That's kind of nice. But in this case, I'm going to get rid of that none again, skipping that, whatever that means. Not want to talk about it. And I'm ready to go to start filling this in. So what do I want my students to contain? Well, I want them to contain a name. I want them to contain a GPA. And maybe I want them to contain their age. And finally, what could be useful? Well, I could do like a sophomore standing. Oh, major, that's good. A major. Okay. So the reason I picked these is because they're different types, right? GPA is going to be probably a float. Age can be an integer. Major is a string, and name's also a string. Okay. So when I create it, I want to pass these in, and the order that you put this matters. So you gotta make sure you remember the order. So in this case, I'm going to go ahead and say name, or I'm going to shorten them, G, A, and M. Okay. So name, GPA, age, and major. And so now I want to assign all of these. You don't have to make them lined up. I just like to make them look pretty. And you want to assign all of these to the right ones. Make sure you don't screw that up. Okay. Now, other programming languages, you declare your variables separately, and then you refer to them in your constructor if you'd like. Again, in Python, that does not work. You just have to set things in the initializer. So in this function is where you're actually creating the variables. All right. So that's it. That's all I got to do. My class is now created. So now, if I want to make an object or of this class, I'm going to call this, I'm going to make a list of them actually. So I'm going to say my role. What's a better name? Not role, maybe my classes. Let's call this the DA621 role. So DA621, that's going to be the name of a list of students that are enrolled in my class. Okay? So it's just an empty list. So now I want to make the objects and insert them there. Okay, so I'm going to start with making a student. And now I'm going to go ahead and make this be student type. And I'm going to insert all the things. So the name is going to be Rick. Their GPA is going to be 3.7. Their age is going to be 19. And their major is going to be film. Okay? So that's a student. Now, if I want to insert it into my roster of students, I can use my append, and I can just append student in there. I can make another student. So I could use the same variable name, but I'm just going to call it a different student. And so this is going to be Jane, and her GPA is 3.9. Let's say that goes to that detail. Her age is 21 and she's majoring in biology. Okay, and now I want to put it in the roster, so I can do append and I can do student 2. I could append multiples of the same one, like there's a clone of Rick or Jane. I'm not going to do that for now. One thing that is interesting though is that you can make these on the fly. So like I can do append, and then in here, instead of appending a student name, I can actually create it. So I can say like append the student type and then pass in the parameters. So let's say this is the third student whose name is Bob, and Bob has a 3.1 GPA. He is 20 years old, and his major is computer science. Okay. By doing this, I am creating the object and appending it at the same time. So this is like combining these two lines. Okay, it's the same thing. So anyways, now that you made it, you can go ahead and print out contents of your list. So let's just try printing out and seeing what happens. So let's say print, and let's just print DA621 and just run this and see what happens. So you can see that when you call print on this, whereas if you call print on a list item, you actually get the contents of a list. Here we are getting these object things that are weird. It says main, student type, object, and some address, and we're getting the three of them, but we're not actually getting the objects themselves. Okay, so that's something that you'll notice with a class, that if you want to print out the member like details of a class, you can't just call print and then list the class name and then just assume that it's going to work, because it will not work. You need to create a special function for that, or you need to print out the specifics. So before I show you more into like how to print out the whole class, let's just go ahead and try to print out an individual piece of this. So let's say we want to print out the first student. And of course, if I do this, you're going to see that again. We're only going to get this like weird detail out printed. But I still can access the individual elements. So I can do dot, and then I could say something like GP or name. Let's say name. That one's easier to see. And you'll see that Rick gets printed out. I can also use something like this, and then autocomplete usually will show you all of the elements of that class, all the members. So you can see age, GPA, major. So that's kind of nice. That doesn't really work with the list, because the linter here is not that good, I guess. But you can also do that if you have an individual object like this. Okay, so that's kind of nice too. When you're coding, it makes it more convenient to be able to remember. Like if you're using somebody else's code and you don't remember what the names of the variables are, you can use the autocomplete and you're in business. Okay, but you can print out each student's name, or you can print out their age. I could write a for loop, say like for S in DA621, go ahead and print out their names. So I want to print out all the names of all the students enrolled. I can do that, and get rid of those. Access that. Stop this. Run it. There we go. Rick, Jane, and Bob. Right. If I want to print out their names and their major, I can do s.major. You can see Rick film, Jane biology, Bob computer science. Bothers me, so I'm going to put a comma between them. Looks nicer now. Okay, so that's nice. But like I said, you can't just go ahead and say like print, like, you know, suppose that I just say, instead of printing all of this, I want to just say print S. So I print out all details of the student in a nice way. You see that doesn't work as is now. The reason for that is because Python does not know how you want it printed. Like, you might be thinking in your head, well, I just want all of these things to print out kind of like this. Python doesn't know that. For all it knows, maybe you want to print out just this guy, or maybe you just want to print out the numbers. Like, it doesn't know what you're trying to do. So you need to tell it by writing another function that says, okay, this is how I want you to print this, okay? And for that, the function is called str. So let's go back to our class and let's write one more function. So this function is going to be 2 underscores str, and then also the self, and you don't need to put any additional parameters. Okay? So when you do this, just for now, I'm going to go ahead and write return here and just write hello. And I want you to see what happens when you run this. Instead of printing out the memory stuff that we were printing before, so here, before and after, we're printing out all this main, basically the type object. We are now going to print out whatever the function str returns, which is the word hello. So now all you got to do is basically change this to print out whatever you want to print for the class. So my recommendation is just to create a variable here and then do the formatting that you want. So we're going to say student. I'm going to put in their names. So I'm going to concatenate the word name to that. And then I'm going to concatenate a line feed. And then I'm going to also concatenate the GPA. And then I need to convert to string the GPA value because it's a float. And then maybe keep put it on another line, concatenate to all of that. The age, and then put also concatenate that to or convert that to a string so it doesn't give us errors. Put a line feed after the age. Also line feed here. And then finally we can put in the major. So major. And then go ahead and say major. Notice that I'm not putting the word self before that. I think that we'll see. It might make me put it. Remember off the top of the bat, he'll yell at me. Yeah, he yelled at me. All right. So I need to put self, so that it knows that I am talking about the variables that belong to this class. So as long as I do that, then it will not yell at me. Oh, and now I need to not return hello, but return the string that I just created, right? So it's massive string. As you can see here now, we got everything. Student, Rick, GPA, age, major. And you can see that that works for all of them. So now if I get rid of this line and just print out S, which is the student, you will see that it prints them out. Now I don't like that. I want to see more, like I want to see maybe some like asterisk or something to separate them better. So I'm going to go ahead and do that. Something like that. And maybe like an extra line feed. Close enough. Oops, I want that random 6 printed. Almost there. One more line feed here. There we go. That looks nicer. So you can see we got the students. They're nicely separated, so we know the difference between them. And that's it. Maybe instead of student here, it's just saying name. And maybe here, we'll make it cool. Putting that. And then 2 more asterisks. And I think I'm happy now. There we go. Yeah, look at that. That looks nice, right? So as you can see, not only does it make it nice and easy when you want to print a student, if you had this as a list and you called to print the object that was a list, it would just print out like a bunch of values with commas and, you know, the brackets, right? Look at how nice you can make this print out. It's much, much nicer to keep your data like this. It's nicely contained. You know, you're reading in a row from a data set. You can make the entire row, like each of the columns, you make an object here, and then you create your string function, you print it out the way you want it to do, and it'll look much, much nicer. So it makes your coding easier, it makes output look much nicer, and it's just way more organized. Like this is the way you want to do this kind of thing. Okay, so let's go back now to just talking about the concept of classes for a second. So you'll notice that I have 2 things that I have had in my class. I have all these fields that I'm referring to, the X, Y, Z, and all the things that I've made. But I have functions, right? I have this initializer function and I have this string function that we've seen what it's useful for. It turns out that your classes can have more than just those functions. It can have as many functions as you want, and that's another way to contain the data. So that kind of brings us to some of the basics of object-oriented programming, okay? So the idea behind object-oriented programming is that you want to have data and operations of that on that data. And you want to sort of contain that within an object. Why do you want to do that? Well, because it makes sense, right? So if you're writing code meant to process specific data, so for example, let's say we have a student class here, and we want to create a function that is going to give us the average of the GPAs. That is a function that is specifically relevant to our data set, right? Because we have GPAs involved. And while you could write a function to compute the average in general, sure, we have a specific function that says, like, give us the GPA average of my class, the DA621. So it makes sense to contain that operation of computing the average to only work for our data that we know is something that you can compute the average on. And so that's the idea that is known as encapsulation. And is one of the main components of what object-oriented programming is all about. You want to encapsulate your information. You want to have all of your data and the operations that you may or may not perform in that data to be all encapsulated in one bucket that you can work with. Okay? If you're curious, some of the other cornerstones of object-oriented programming is inheritance and I should know this by heart. Encapsulation, inheritance, and what's the third one? It just left my mind. Hold on a second. Polymorphism. Yes. Okay. Polymorphism means multiple shapes, and we are definitely not going to touch on that in this class. I do have it in my other videos. And inheritance, we probably won't touch on either. But you can also check my videos out if you're curious about that and how that will kind of relate to Python, okay? But at least we have at least one of the three concepts that you understand what it is, and that's encapsulation, okay? So let's go ahead and do that. Let's go ahead and add some functions here. So suppose that I want to do that. I want to compute the GPA of the cohort of the students here. So what I do is I just write another function and say get, let's say get the GPA average. Okay, you can do something like that. And then you're going to put that self always. And again, just put this str. Don't worry too much about that. You can just put a colon too. And so what do you want this function to do is, well, right now, suppose that I just wanted to just return the average, the GPA. Let's do that actually first. Let's do get GPA. So you could say return self.gpa. And what this is going to do is if I call out on the student, so if I say like student2.getGPA and I print what this returns, it's just going to print out that student's GPA. As you can see by this, 3.94, okay? But now if I would like to actually have a function that computes everybody's GPA, what it's going to need is going to be a list of objects that you want to compute the GPA on, right? So define average GPA, and I'm going to go ahead and say that this should take a list of items. So I'm going to say it's just going to be called cohort or something. I believe cohort stands for students. And so now what it's going to do is it's going to take the cohort, which is a list of them. It's going to say for each student in the cohort of students, I'm going to say student.gpa. The autocomplete is not working there because it doesn't know that this is a student type, but you know that it is. And also we need to have a count so that we can do the average on. So then I can say count plus 1. Take the student GPA and also do the sum, start at 0, so we can do sum plus this. And once it's done, we want to say sum divided by count. But we just learned exception handling in the last video, so we should probably practice that. Let's go ahead and put that in the try block. And then we're going to say division by 0, something like that. Okay. Return that result because that's the average, right? Okay. Although if we have the division, then maybe we should return 0 as a placeholder so the thing doesn't crash. Okay. So let's go ahead and try that. So we have our function that we need to call it on something. So, oh, I forgot to put self. And then you need to call it on the student. So even though you have a lot of students, you need to call it on a student, or you could just go ahead and say, yeah, because data 621 is not an object. It's called student type. So you could say student type dot and then get GPA. But the problem with that is that you have the self here, which requires an object to call it on. So you have to call it on a specific student. If I get rid of that, then I believe you won't have that issue. But we'll see. This is technically a static function. It's called static, but again, don't worry about the terminology for now. So I'm going to pass in here the DA621, and if everything is good, then this will print out the average. List object has no attribute GPA. Oh, I called the wrong function. I said get GPA. It's get average GPA. There we go. And we get that the average is 3.58. Is that correct? I mean, it looks kind of correct. This is 3.1 really lowers the GPA of these two, right? So we got basically 3 of them. And you can see that, yeah, that sounds about right. So there you go. So notice that I didn't put a self here because that way I can call it by naming the type of the class. If I had a self, such as with GPA, with this one, I can't do this. I can't say like student type get GPA, because if I do that, it's going to be like, yo, what is the self of this? Like, whose GPA do you want? We need a student to figure out whose GPA you want. And so this needs to be actually a student to be able to get his GPA. This function, on the other hand, does not have a self, so it doesn't require that, because while the function is part of the class, it doesn't interact with any of the fields of the object, because there's nothing in it. If you see, there's no self anywhere in here. Whereas here, I am saying, yeah, get me this person's GPA. Here, I'm not talking about that. The only reason that I'm making this part of the class, because this could be just like a normal function and it would work the same way, is because it just makes more sense to have it encapsulated, okay? So that's classes, functions in general for your classes. And that's really the main component. Like I said, there's a lot about classes that I could go over, but it's not really necessary for the basic usage of classes. You now know how to create these classes and fill them with different types of anything you want. And by the way, you could make lists inside of your classes too. I didn't really make a list in here, but you just make a list and you initialize it and you fill it with data. You can make functions that interact. So for example, well, I can directly update values here by saying something like, let's say that Bob did better and his GPA went up. So let's modify him. So 621 index2 dot GPA is going to get 3.4. So if we run this again, you can see now his GPA has been updated to 3.4. So while I can do this, I can also create a function that can do that for me. So I can call that like my set GPA function, passing a parameter, which is the new GPA, and then assign it. Again, this one has self because I'm referring to a specific instance of this class. And so now, instead of doing this line of code, I can say DA621 second student, set GPA to 3.4. Notice I don't need to pass any self stuff here because it's getting it from here. So if I do that, as you can see, I still get the 3.4 there. And you can see that the average went up because Bob is dragging down the average of the entire class. Don't be like Bob. Be like Jane and have a good GPA. But yes. Okay. So yeah, that's really all I want to cover with classes. I'm trying to think if there's anything in particular. I will leave a link in the description below of the documentation officially from Python. You'll see that it's pretty big for classes because there's a lot of things you can do with classes. But like I said, I'm not going to go too much into them because I really just want you to be able to use them as a structure, to have a structure to your data, or to contain functions within a specific class, to have that concept of encapsulation. And really anything other than that is not necessary. But that link will have descriptions on inheritance as well. Inheritance is just a 2-second version of inheritance. Is like you really like the student class, but like you want to add one extra field to this. Like you want to add the field of like their NCID number or their identification number, social security or something. You can modify your original class, but maybe not all students have it. Maybe it's something that you added to your system in the future. So what inheritance does is it takes this organization that you created for the class and copies this over to a new class with a new name, which then you can add more things to it. So you can add the NCID number or the social security number in there. So that's inheritance in 5 seconds, of course. And it's pretty easy in Python to do. It's not bad. Like if I just show you the basic version of it, we'd be done in 10 minutes. But it's just unnecessary, and I don't want to confuse you with stuff that you're not going to be using day to day. Now, the bigger reason for classes and covering it is because when you're using a library, all the libraries are organized by classes. Whether it be something like matplotlib or pandas, you'll see that you're using the dot a lot. And that's because it's a class and you're accessing member functions or member variables. Just here off the bat, we know we have a list, which is DA621, right? So if I say DA621 dot, failed. There we go. We can see a lot of things fill up here. Well, guess what? DA621 is a list, and list is a type of a built-in type in Python, but it's a class too, technically, and it has a lot of member functions and member variables. Append, the append function that you use to insert things or to append them into your list is a function that's member of a class. So that's why the dot is there. And you can see the parameters of the function right there, which right now says objects none, but it says any, because that's what you're appending, right? And just like it, list has other functions in there. It has sort, which will sort the list of things. So you can see on the left there, it's kind of cut off, but you can see the autocomplete is telling you what the parameters are of the function and what it does. It's all part of members of a class. We have pop, we have insert, index, extend, count, copy, clear, append. And then these, all of the ones that have these underscores, some of these might be functions, but some of them are actually variables. And they're more like internal ones that you shouldn't be modifying. You should only be messing with the ones that don't have underscores in front of them, like this. But yeah, so whenever you're using a library, now you kind of know the organization of that. It's a class, it has functions and variables, and then when you're looking at the documentation, then you can see what those are. Okay? So that's all I want to say about classes, and it's not the last time you'll see them. You should be using them, you should be embracing them. They will organize your code much better. Lists are awesome, and you should be using them for a lot of things. But when you're dealing with with data that is structured and has rows and columns associated with it, column IDs. Classes is just a better way of keeping track of things. So I encourage you to use that. It'll make your coding much easier to read for someone else and for you to use and debug. And once you build these classes and you set them up with all the operations you want, it makes the code very portable and able that you learn inheritance, because then you can actually use your code in the future instead of coding everything from scratch. So you start building your own sort of like personal libraries of code that you can expand upon, and you become a much stronger coder. Okay, so with that, I'm going to wrap up the video. I thank you all for watching, and until next time, take care.